Hey everyone. I want to start off by hoping that everyone had a great Easter. Wasn't probably the long weekend we were all looking for, but I hope everyone's staying safe. I hope everybody's practicing social distancing. Um, I hope you're doing what you have to do for you to keep yourself healthy and mentally sound during these times. So I sincerely mean that, and I miss being in the classroom with you guys. You guys were a fun bunch of students. We were lots of characters. And I really enjoyed coming to this class every day. So thank you guys for that. And I hope we can finish strong online. I know it's a little different, obviously, but we'll keep doing our best. And to keep it as real as we can, I got a bit of a joke for you. I have an uncle that lives out west, and I was talking to him, and he said, "Hey, I think I know why everybody's panicking over the toilet paper and why so many people need so much toilet paper." And I said, "Oh yeah, what'd you figure out?" And he said, "Well, I was at Costco the other day and I coughed and the guy next to me almost shit himself." So, that's kind of stuff going on. You're going to need a lot more toilet paper. Anyways, little humor. In serious times, not to make light of it. Anyways, I wanted to take up Unit 5, Handout 2, Page 1. We did 1 as a example for you guys, and then 2, 3, and 4. So not a lot of questions. We're easing in here. So I put some pictures on the board, and then how I answered the questions to get the correct answer. So for question 2, now I got voltage and current drawn that way. They could be drawn the other way. It just says the current and voltage are out of phase by 27 degrees. So I just coast 27 degrees, and then I get a decimal of 0.89. I can multiply that by 100 to put it into percentage. You can leave it as 0.89. When it comes to a test, either would be correct for me. Question 3. This time it says the current and voltage are 72, or the power factor is 72, so 72%. So I know that decimal came from a cos of an angle, and it was 0.72. So I plugged in 0.72. I know there's going to be an angle that'll be greater than 27 degrees because 0.89 was 27 degrees. So have a worse power factor will have a greater separation between the two angles there. So 0.72, again, voltage and current, they can go either or. So now we're going to do the opposite. We're going to inverse cos 0.72, and we get an angle of 43.94 degrees for question 3. Question 4, I did a little bit more than it asked for, but I wanted to show you that you can always check your work. Like every question I think we've basically done to this point, if you want to go back, there's multiple ways to check your work, to rework your numbers into formulas to ensure that you're getting the right answers. So it says that the current lags the voltage by 40 degrees. So I just decide I've left my current on the bottom. I put the voltage up there. I got 40 degrees between the two. You can see voltage or VA is in green, current or watts I got in purple. And then I kept those colors consistent as I worked through the formulas. So don't forget the voltage and the current, that's your VA. So VA, volt, amps. So the voltage times the amps equals your VA. So for this question, we got 720 VA. I know there's a 40-degree separation between the voltage and the current. So now I have a triangle with 720 VA and 40 degrees. So again, we're just using SOHCAHTOA, but instead of calling the hypotenuse, it's the VA. So my power, which is what the question asked for, it wants the power in watts. Power equals my VA times cos of the angle. I know it's going to be times cos of the angle and not divided by cos of the angle because my power has to be smaller than my VA. Has to be. The VA or the hypotenuse will always be the longest or the greatest magnitude of the triangle. So I need to times my VA by a decimal. I get P equals 551.6 watts. Now I can leave that. That's the correct answer. I'm correct. I could go backwards. I knew the angle, and now I know the two sides. So if you can see, I got step 4 in red. I went power factor because this question never gave us the power factor in a percent or a decimal. So I can go power factor equals 551.6 divided by 720. That gives me 0.766, which to me at this point doesn't mean anything. But I have to invert the decimal, like we did in question 3 to get it back to an angle. So if you go to step 5 at the very bottom of the board, I did cos invert it 0.766 and I get an angle of 40 degrees, which checks out. So 551.6 watts, which was the missing number at this point, has to be correct. So I checked my work, and that is a good way to ensure you're getting the proper numbers. Any questions with questions 2, 3, or 4, please ask them in the discussion board so that other students can see the questions being asked, and it's going to operate more like a classroom setting, okay? I'm going to post a couple more videos today and show you handout 3. I'll take up a question from handout 3 and let you guys roll with those for a bit. All right, stay safe. Keep the questions coming, and otherwise I hope everybody's doing well.